All right, awesome pre-calc students. This is 7.6. This is the last section in chapter 7, and then we will soon have a chapter 7 test. Okay, so keep that in mind. Before I give you all of the identities for the double angles, I'm going to prove it first to see how or why we have what we have, or we are using these formulas. Okay, so the first thing is I'm going to write an identity that you already know, such as sine of alpha plus beta. Okay, so right now, can you do me a favor and give me that identity? What is sine of alpha plus beta? Okay, so did you write down sine of alpha cosine of beta? Because it's an addition of sine, I'm going to add here. Oopsie. And then I would write sine. Actually, I think I normally write cosine first, right? So cosine of alpha sine of beta. And it doesn't really matter, okay? So what if, if alpha and beta are the same, okay? So what I mean is that let alpha be theta and also let beta be theta, okay? So this means alpha is the same as beta because they're all what? Theta. So what I'm going to do is I'm going to substitute this in, okay? So sine of alpha now is theta and beta is now theta. So I'm going to write, every time I see alpha and theta, I will now use, every time I see alpha and beta, I will now use just theta, okay? So, and yes, in mathematics, what we do is we manipulate one equation to come up with another, okay? So in here, sine of alpha plus alpha is now sine of, not alpha, I'm sorry, sine of theta plus theta is now sine of 2 theta, okay? Equals to, well, would you agree that sine of theta, cosine of theta, in over here, I can write sine of theta in the front, right? Because addition is commutative, and so is multiplication, okay? So because multiplication is commutative, that means I can move things back and forth. So would you agree I can combine these because they're exactly the same? So sine of 2 theta is 2 sine of theta times cosine of theta. And guess what? This is a new identity, okay? So new identity, highlight, and let's write this up here, okay? And yes, that's how they come up with one new identity. They manipulate the equations that's already known. All right, so sine of 2 theta is called double angle formula because instead of 1 theta, it's now 2 theta. That's why it's called double. So here's our first identity. Sine of 2 theta is always 2 sine of 1 theta times cosine of 1 theta. So that's how they came up with the double angle identity for sine, okay? So now we can also work with cosine, okay? I'm gonna use different ink. All right, so I'm gonna start out with the same thing, cosine of alpha plus beta. Okay, do me a favor and write down that identity, please. Okay, so let's say cosine of alpha, cosine of beta. In cosine, the signs are opposite. Sine of alpha and sine of beta. So similarly, I'm going to manipulate this the same way, okay? We're going to make alpha and beta the same, okay? So let alpha be the same as beta, and let's all call it now theta, okay? And yes, in mathematics, you can do that. So what if that's the case? Then now I would have cosine of alpha is now theta, so is beta, okay? So every time I see alpha and beta, I will now put in theta because That's what I assume over here. So sine of theta times sine of theta. Well, cosine of theta plus theta is now cosine of 2 theta. Okay, see how the double angle is coming around? Equals cosine of theta times cosine of theta is now cosine square of theta. Okay, minus sine square of theta. Okay, all right, so guess what? This is our identity for cosine of 2 theta. Isn't that beautiful? Let's write it up. Okay, cosine of 2 theta is cosine square of single theta, take away sine square of single theta. But with cosine of double angle, we can also manipulate this. Okay, remember this identity that we had before. So identity, right? Sine square of theta plus cosine square of theta equals 1, right? So would you agree that I can admit cosine square of theta equals 1 minus sine square of theta? So what I can do with double angle identity is I'm going to create a different one, just based on other things that we already know. Every time I see a cosine square, I can now put in 1 minus sine square of theta, and then bring this down, minus sine square of theta. So cosine of a double angle is, here's another one. Now, these all come from the original, okay? But sometimes one is easier to use than other, so that's why we want to write all of these down. So let me write this one down, okay? And I want to write that in red because that's cosine of a double angle. All right, so it's 1 minus 2 sine square of theta. Okay. Now, well, technically, I don't really have to substitute in cosine square. I can technically substitute in sine square. Would you agree? Sine square of theta equals 1 minus cosine square of theta. Okay, so I'm going to do the same thing, right? I'm going to take this, what we already know, okay? Cosine of 2 theta equals, I'm going to keep cosine square of theta, but substitute in sine square is 1 minus cosine square of theta. Then from here, cosine of a double angle is, distribute the negative sign to see what I have, minus 1 plus cosine square of theta. Combine like terms, so sine 2 theta equals 2 cosine square of theta minus 1. Guess what? This is another identity for cosine of a double angle. So if you can see, cosine of a double has 3 different equations, okay? Oopsie, I meant to use red. All right, so here's another one. Cosine of a double is, now, do you have to memorize all of this? Yes, okay. But if you don't, like on the test, if you don't have it all memorized, technically, can you go and like derive it from original or from scratch? Of course, okay. So if you get stuck on the test and don't remember what to do, just start from scratch, okay. All right, we got sine of a double, we have cosine of a double. Guess what? We can also do tangent of a double, okay. So what would I do with tangent of a double? I'm going to do the same thing. So I can also manipulate tangent of a double. Tangent of a double, though, it's gonna be a little bit longer, so I'm just gonna give it to you. Okay, are you ready? I'm gonna use a different ink. How about green? So tangent of 2 theta is, in your book, I'm going to give you 2 tangent of theta. And should I do this with you from scratch? Maybe I should, huh? Okay, let's try from scratch. That way you can see where this comes from. All right. So just like the other ones, okay, I'm going to start with you from scratch. Are you ready? So tangent of alpha plus beta equals to tangent of alpha plus tangent of beta all over 1 minus tangent of alpha times tangent of beta. And again, let alpha be exactly the same as beta. which let's call it now theta. So tangent of theta plus theta is tangent of theta plus tangent of theta all over 1 minus tangent of theta times tangent of theta. Then from here, can you see what's going on? Why don't you simplify that for me? Do you see where tangent of 2 theta comes from? Tangent of theta plus tangent of theta is 2 tangent of theta. Would you agree? All over 1 minus tangent times tangent is tangent square of theta. So that's where they came up with this double angle for tangent. Okay, so that is how we came up with all of our double angle identities. Now, do you need to know this? Do I need to memorize this? Oh my goodness. Yes, yes, yes. Memorize, please. Okay. I would not give you these at all on your test, so make sure we know where or how or what the double angle identity. Okay. Example 1, use the half angle formulas to find the exact value of each. And in here, I gave you 3 questions. Question A, question B, question C. So question A said sine of 22.5. And you can't use the calculator because you have to find the exact value. And in addition, it says use the half angle formulas. Well, half angle formulas are defined for you already here. Whoa, yay! See right here? Da-da-da. There you go. So this one, I'm using sine, right? But before you can go and use the half angle formula, the sine identity says, according to what you see up there, sine of alpha divided by 2 equals plus or minus big radical 1 minus cosine of alpha all over 2. And that 2 is under the radical, and that's important, okay? So make sure when you write it, the 2 is shown when you're writing that it's under the radical. So the question is, you are provided with sine of 22.5. You need to rewrite this, okay? Sine of what divided by 22.5 gives you, sine of what divided by 2 gives you 22.5, okay? So now sine of what angle, in this case is in degrees because there's a bubble right there. What degrees, when I take it and I divide it by 2, it will give me exactly the same. So these two things should be exactly the same. So sine of what divided by 2 gives me 22.5. Well, the answer to that is 45 degrees, okay? And what's the trick? The trick is you take this angle, 22.5, you multiply by 2. So you're kind of going backwards. When you multiply by 2, it's 45 degrees, okay? And this always go in here. So that's the trick, okay? So next, you would need to use identity, okay? So now I have sine. Alpha is now 45 degrees. Here's alpha, get a different color. Here is alpha. Alpha is 45 degrees, but I'm gonna write the identity first. Are you ready? Sine of alpha, 45 degrees all over 2 equals, okay? Now the plus and minus, you have to pick one. Pick only one. Plus or minus, not both. So keep that in mind. Well, 22 degrees, 22.5 degrees, I should say, that's going to be in quadrant number 1, okay? So in quad 1, I have to pick positive. So I have to pick positive, and you only pick one, not both, okay? So 1 minus cosine of 45 degrees all over 2. Then from here, I will simplify. Since we have chosen a positive, because sine, again, 22.5 is in quad 1. In quad 1, sine's positive, cosine's positive, tangent positive. So in this case, we pick quad 1, which is positive. I don't need to write positive throughout, but now cosine of 45 degrees is rad 2 over 2. And dividing by 2, I can write it this way with extending my radical sign. Dividing by 2 is like multiplying by a half, okay? So from here, I'm going to do a common denominator. See this right here? Let's do that first. And that right there, common denominator of 2. So change the 1 into a 2. Extend my radical line. Dividing by 2 is multiplying by 2. So think of it that way. And simplify some more. Now under the radical, I can put it over 2 like this. So this is 2 minus rad 2 on the top times 1/2. Okay. Well, this is really then 2 minus rad 2 all over 4. What's square root of 4 on the bottom? On the top, there's not much you can do. You have to leave it exactly like this. 2 minus radical 2. Because you can't simplify out the top. But on the bottom, I should write that 4. And then I'm going to simplify one more step. On the bottom, when you have one big radical, you can write it as 2 separate radicals, only when you are dividing and multiplying. So when I write it to 2 different radicals, the top, you have a radical under a radical, which cannot be simplified, but square root of 4 is 2. And that is as far as you can go with sine of 22.5. Now we can do the same thing with cosine, okay? Cosine of 5 pi over 12. And as you know, denominator 12, you can't do anything with it, okay? You have to use a sum of difference or half angle. In this case, it wants you to use half angle. So the same thing as earlier, okay? Cosine of what angle? When I divide it by 2. Okay, so my goal is, what is this angle and this angle? They have to be exactly the same. So when I divide it by 2, what is going to give me 5 pi over 12? Okay, what angle, when I divide by 2, equals 5 pi over 12? So again, just like earlier, you go backwards, okay? You take 5 pi over 12 and you multiply by 2, or 2 over 1, okay? Dividing, when you go backward, is multiplying. And if that's the case, this is reduced down to 6, and this is 1. So the answer is really 5 pi over 6. And leave it as 5 pi over 6. Don't try to convert, because 5 pi over 6 is going to be your identity. So the identity says cosine of alpha divided by 2 is either plus or minus. You have to pick one. 1 plus cosine of alpha all over 2. Well, your alpha in this one is really it's really 5 pi over 6, okay? The division of 2, it's already there, so they are exactly the same. So now I'm going to write cosine of 5 pi over 6 divided by 2, okay? The dividing by 2 is just letting me know that you're using half angle. Now you have to pick, okay? Pick positive or negative. Only one. Pick positive or negative, not both. Not both. Okay? So 5 pi over 12. You have to decide what quadrant that is in. So let's talk about denominator of 12. Pi is right here with denominator of 12. That's really 12 over 12 pi. 6 over 12, it's pi over 2. So 5, again, is in quadrant number 1, right? So 5 pi over 12 is really right here, okay? Somewhere there, 5 pi over 12. Because you're in quadrant number 1, I will pick positive, okay? Not all the time that we will be in positive quadrants, so make sure you understand why we pick what we pick. So now we're going to write 1 plus cosine of 5 pi over 6. All division by 2. And again, 2 is under the radical. And slowly work out your algebra 1 skills, okay? So now, since we have chosen positive, I don't have to write the positive in front all the time. So it's going to be 1 plus. What is cosine of 5 pi over 6? I would love it if you write the answer down for me. Cosine of 5 pi over 6 is what? Did you say negative radical 3 over 2? Awesome. Okay. Don't forget the negative, because 5 pi over 6 itself, it's in quad 1. But half of that is 5 pi over 12. Now, dividing by 2, I can write division this way, because soon I will be flipping it. Okay. Next, I am going to find common denominator for the inside. So see this right here, because you have to add first before you divide, right? So the common denominator would be 2 over 2 minus radical 3 over 2. Now I will multiply by its reciprocal. And then from here, I now have under 1 radical, so 2 minus radical 3 all over 2 times, oops, you guys see how I wrote 1/4 right here? I did the math already in my head, so I knew that was going to be 4, so, but this should be a 1/2 still. Now I can write a 4. So this is 2 minus radical 3 all over 4. And remember, earlier we said if you have one big radical and they are dividing, you can make them into 2 different radicals. So if I do that, I would have 2 minus radical 3. Not much you can do with the numerator, but the denominator you can simplify. And this is my final answer for cosine of 5 pi over 12. Okay, and we have one more for example 1, and that will be it. I'm not going to do any more for this set of video. Well, cosine of 7 pi over 8, let me tell you something. I did not give you an identity for that at all. But that doesn't mean you can't find it, okay? Cosine, so let's first find an angle. Cosine, I'm sorry, not cosine, cosecant. Cosecant of 7 pi over 6, no identity is given. But that doesn't mean you cannot find an answer for it. So the first thing I would like for you to do is 7 pi over 6 is the angle that we're supposed to use. So now I would like for you to do cosine of cosecant. Oh gosh, why do I keep saying cosine? Cosecant of what angle in radians when I divide it by 2 equals to 7 pi over 8? Take a minute or two to think about it. Remember, you can also go backwards, okay? So don't be shy to go backwards. So dividing by 2, when you go backwards, it's like multiplying, okay? So when I multiply by 2 over 1, I can simplify this to 4, and that's 1. So that's 7 pi over 4, and leave it as 7 pi over 4, okay? All right, so now let's use identity. I did not give you any formula or identity for cosecant. So that means I will have to use 1 over sine, right? 1 over sine is cosecant, and perfectly okay. Don't be shy about using 1 over sine. 1 over sine at alpha divided by 2 equals 1 over big radical. Okay, there's still plus or minus in the front of this radical. 1 minus cosine of alpha all over 2. Then from here, I'm now going to write 1 over sine of, your alpha is 7 of pi over 4. So 7 pi over 4 divided by 2. You don't have to do anything here. This is just writing out the formula. This is the part where you have to do something. All right. Oops, I forgot the 1 divided by. Okay, so 1 divided by big radical. Okay, 1 minus alpha is 7 pi over 4. So I'm going to write everything out first before I do the math. So cosine is 7 pi over 4. I'm just going to go and multiply by 1/2, okay? Because what's happening is, as you can see, dividing by 2, let's go back. Can you guys see that dividing by 2, it's ending up to be multiplying by 1/2 in the end? So I can just go straight through and say, hey, you know what? I know it's going to be divided by 2, so I'm just going to multiply by its reciprocal right away. Okay, so now you have to pick. Okay, I want you to decide, are you going to pick positive or are you going to pick negative? So here we go. Pick positive or negative. Then go back to the original angle. 7 pi over 8. That is in quadrant because this is a pi. And pi with denominator of 8 is 8 over 8. So 7 pi is over here. Sine in quad 2 is positive. That means cosecant will also be positive. So you're going to pick positive angle. And then, here we go. Oh, and then I forgot the 1 divided by again. Okay, so let's do 1 divided by big radical. 1 minus cosine is 7 pi over 4. That's in quad 4, so that's going to be rad 2 over 2 for cosine. And again, I'm going to bring down the positive 1/2 here. Extend the radical. Keep on going. Next is I'm going to find common denominator. Common denominator is going to be 2 minus 2. 2 over 2 minus rad 2 over 2 times the 1/2. Okay, keep on going. Then 1 over. Now the denominator is the same, so 2 minus rad 2 all over 2 times 1/2. Keep on going. 1 over big radical. 2 minus rad 2 all over 4. Okay, but as you know, you can take out the denominator because square root of 4 is 2. So 1 over radical 2 minus rad 2 all over 4. I'm sorry, all over 2. Square root of 4 is 2. Square root of 4 is 2. Okay, so what do I do now? I have so many fractions. Well, it's not too bad. 1 divided by radical 2 minus rad 2 over 2 is like 1 multiply 2 over square root of 2 minus rad 2. Okay, so now this is really where I am. But I can't have radical on the bottom, so this is where I need to do a little bit more math. So it's really where I am is right here. I'm going to go in and multiply, not the conjugate, but an identical radical. That's the only way that you will be able to get rid of that radical. So when I multiply by the identical, I now have 2 times 2 minus radical 2 all over. The radical times the radical, now the big radical is gone, but I still have this little guy, this little radical right there. Oh man, are you kidding me? No, I'm not kidding you. Okay, now I can multiply by the conjugate. So ugly, isn't it? Sorry. Okay, I did not create this problem. I stole this from your book, and so you cannot blame me. I'm just the messenger, okay? Then from here, because I know a lot of you are upset, oh, why is she giving me this? I'm not giving you anything. I just simply pick out problems from the book. Okay, 2 times 2 is 4. Rad 2 times rad 2 is now 2. On the top, I'm just going to multiply this out to see if it's any cuter. Hopefully it is, but if it isn't, don't blame me. Okay, on the top, here we go. 2 times that is going to be 2, and this big old ugly radical, this fat one. Okay, and this times that is going to be a plus 2 outside. Inside, I have 2 times 2 minus rad 2. I know it's ugly. I'm not denying anything. Okay. Okay, let me double check to see. Oh, no, I'm sorry. 2 times that is 4. My bad. There you go. All right, so here we go. So now this is what I have, and it's so ugly. I can't stand it, but I'm just the messenger, so don't shoot the messenger. All right, on the top, I have 4 and 2, so I can take out a 2. So now I have 4 rad 2 minus rad 2, so that's 2 rad 2 minus rad 2, plus I took out 2 in the front, so now it's just going to be a 4 minus 2 rad 2. Okay, inside, all of it inside. And then I can cancel that, and that's it. So 2 rad 2 minus rad 2 plus big radical 4 minus 2 rad 2. And that is the end, and I know that's so ugly, but I did not create the problem. Now, that is really advanced, right? That requires a lot of algebra. And so, would you give me full credit if I get to here? Let me see where we were at. I will give you full credit if you get to here. okay, before you rationalize at the bottom. But the reason I do all the way, because sometimes if it's a multiple choice in the book, I do not create the problems, and the book has to go all the way. I need you to be able to go all the way. So free response, okay to be here, okay? Okay to stop here for free response questions, okay? But multiple choice, you need to go here. So I hope you understand. All right, so example 2 in 7.6. Solve for theta is in between 0 inclusive and all the way to 2 pi not inclusive. Okay, so A, there's only one question in example 2. Cosine of a double angle, so cosine 2 theta times cosine of theta minus sine of 2 theta times sine of theta equals 1 over 2. Now, just because in your video notes or when I'm lecturing, I'm solving or doing a problem one way, doesn't mean that's the only way that you have to do it. Yes, you can do it whatever way you would like, as long as you come up with a consistently correct answer, okay? So when I see cosine of 2 theta times cosine of theta minus sine of 2 theta times sine of theta, that kind of reminds myself of an identity. So what do I mean by that? I mean by cosine of alpha times cosine of beta minus times sine of alpha times sine of beta. This is an identity for cosine. Would you agree? It's cosine of alpha plus beta. Okay, so well, what's alpha and what's beta? Okay, well, alpha is this. Well, according to this, do you see that's kind of like that? See all the alphas? I'm going to highlight it in yellow. What's beta? Beta is all of this, right? Okay, so when you see this, I'm going to go backwards, okay? So here's the beta. Let's yellow back, okay? So if you can see this, alpha, all the yellows are 2 theta, okay? So if you see this, alpha is 2 theta, and beta, it's really in essence just theta. So beta and theta didn't really change except the variables. So what I'm going to do is this whole thing, okay, going backwards, is cosine of alpha is 2 theta plus theta is now beta, or beta is now theta, I should say. So now I'm going to set it equal to 1/2, okay? Well, 2 theta plus another theta is now 3 theta equals 1/2. Well, cosine is regular function. There's no restriction. And cosine is positive 1/2 in quad 1 and in quad 4. Okay. In quad 1, cosine of a 1/2 tells me that I need to be, now you're going to tell me, fill in the blank. What angle do you think I need to have for cosine to be 1/2 in quad 1? Did you say pi over 3? Beautiful. How about in quad 4? Remember, the restriction for theta is from 0 to 2 pi. Okay, so we had to go a full revolution. Did you say 5 pi over 3? Great. Okay, so from here, you're going to break this up. 3 theta is pi over 3. I'm solving for 1 theta. So I'm going to go in and multiply each side by 1/3. Okay, so that means 1 theta is pi over 9. Then I break it up down here. 3 theta equals 5 pi over 3. I'm going to go in and solve for 1 theta. So 1 theta, multiply both sides by 1/3. So that and that's canceling. 1 theta is 5 pi over 6. Okay, I'm sorry, 5 pi over 9. Now keep in mind that I need to, theta need to go from 0 all the way to 2 pi. So now I need to find this magical thing called the period, okay? Period of any cosine is 2 pi divided by absolute value of b. Well, here's the equation. I want to make sure I highlight this correctly. Here's the equation that I have, okay? So what is the period? Ooh, right there, okay. It's 2 pi. Your b value is this 3 right here. So 2 pi divided by absolute value of 3 is still 3. So the period is 2 pi over 3. Notice how you have two answers already. The first one is theta is pi over 9, and the second one is 5 pi over 9. Well, if it's with denominator of 9, I might as well convert it now, right? So that means I multiply this by 3. That means this is 3, so this is 6 pi over 9. So if I keep adding 6 pi over 9, I would get all of my answers. And hopefully it's not before 18 over 9, because 18 over 9 is at 2 pi. So pi over 9 plus 6 over 9 is now 7 pi over 9. So that's going to be my next angle. So theta equals 7 pi over 9. Highlight that. Okay. Then because it's not anywhere near 18 over 9 yet, so I'm just going to go back and add some more, right? I'm going to go back and add a period. And a period is 2 pi over 3, or with denominator of 9, 6 pi over 9. So now this will give me a theta, a new theta of 13 pi over 9, okay? Well, I can go and add 6 pi over 9 some more, but that will bring me 19 over 9. And remember, our goal is to stop at 18 over 9. So this is the first 3. I'm going to do exactly the same thing on the bottom. I'm going to go and add a period, 6 pi over 9, okay? So that means my next theta, it's 11 pi over 9. I'm going to add some more. Okay, highlight that because that's an answer that I'm going to keep. I'm going to keep adding until I reach near, okay, 18 over 9. So if I add that, would you agree my next angle is going to be 17 pi over 9? Okay, and that's as close as we are going to get because 18 over 9 is 2 pi and we can't even include 2 pi. So these are all of the answers for theta. And guess what? I'm going to have to write it all down, and let's try to do it from smallest to biggest. Theta is pi over 9, okay, 5 pi over 9, 7 pi over 9, 11 pi over 9, 13 pi over 9, and 17 pi over 9. And we have a total of 2, 4, 6 answers. So hopefully you are able to understand that. If you didn't, then please do go back and listen to it again. Example 3 from section 7.6. Okay, the direction says use the information given about the angle, which is called theta, and theta is restricted between 0 to 2 pi, inclusive at 0 but not inclusive at 2 pi. To find the exact value of, and then we have 1i, 2i, 3i, 4i, 5i, and 6i. Okay, so let's slowly work this out. Make sure we're neat. Okay, doesn't look like I gave you too much space, so I'm going to try my best to fit it all in here. Okay, if not, we'll just get a new piece of paper. So we'll start with sine of 2 theta. This is a double angle, so we will need to use the double angle formula for sine of 2 theta. But let's start out with looking at the given information. Okay, they said, hey, cosine of theta is negative 2 over 5, and theta is in quadrant number 3. So what I would do first is I would draw this triangle out. And I would draw it up here since I know I will have a limited space. Okay, so here's quad 3. That's why I'm just going to focus on this. So quad 3, let's draw the triangle. Okay, theta, it's in quad 3. Cosine is adjacent over hypotenuse. Then I would need to find that y value. Let's use Pythagorean Theorem. So y squared is what I'm looking for, plus negative 2 squared equals 5 squared. So y squared plus 4 equals 25. Move the 4 over, so y squared equals 21. So you know y is going to be square root of 21. Okay, now because y is in quadrant number 3, it will also be negative. So now I have a negative square root of 21. So now that we have the triangle given to us, we will now write down the identity for double angle of sine, which is 2 sine of theta cosine of theta. Okay, well, I know exactly what sine of theta is, right? Sine of theta is going to be, look back at the triangle, right there. Okay, so sine of theta is going to be negative 2 over 5, but first let's drop down the 2. Okay, sine is opposite over hypotenuse, so that's negative 2 over 5 times cosine of theta. Cosine of theta, oops, I did that completely wrong, didn't I? Sine is opposite, which is negative rad 21 over 5. Cosine of theta is given to us right here, which is negative 2/5, or you can even look at adjacent over hypotenuse, which is the same thing, negative 2 over 5. I'm sorry about the sign. Sine is opposite, so we are now correct at negative rad 21 over 5. Now we are going to slowly distribute this out, so we are going to have a positive 4 rad 21 all over 5. Rad 21 we can't, I'm sorry, over 25. Oh my gosh, sorry, I'm having an off day. Which happens a lot, doesn't it? Okay, rad 21 can't simplify any further, so guess what? That is my final answer for 1i. Okay. Now let's do 2i's. I'm going to use a different color because I know I'm going to be running out of space. I'm going to try my best to squeeze that all in here. 2i says that I'm looking for cosine. You know what? Let me move it up because I know I'm going to need all the space, okay? 2i. Cosine of 2 theta. Now, cosine of double angle is you're gonna have a bunch of different identities, 3 to be exact. So I'm gonna pick one that's gonna be easiest for me. Now, the reason I picked this one is because the original was already given to us as cosine. I don't have to find sine, so I'm just gonna use what's given originally. So now we have 2 times quantity, negative 2 over 5. I will square that. Then I will subtract 1. Then from here, we're going to work out the math slowly. So 2 times, this is 4 over 25. Take away 1. We're just going to give 8 over 25. Subtracting 1 is like subtracting 25 over 25 due to common denominator. So now I will end up with a negative 17 over 25. So this is the final answer for cosine of a double angle. Next, we will go over to do 3i's. Okay. Now, all of these are really applying the identities. Okay, so if you have it memorized, then it's just going to be so much easier for you. Now, do you have to memorize them? Yes, you are not going to be provided at all of any of these identities. Okay, so 3i says you are asked to find sine of a half angle. Okay, now the sine of half angle is you're going to start with a plus or minus. Okay, then I'm going to do a radical 1 minus cosine of theta all over 2, still under the radical. Then from here I have to decide, okay, is it positive or is it negative? Now let's look at what theta is. Theta is in quadrant number 3. Okay, so what if I'm doing half? Half means I'm dividing it by 2. Okay, so let's take this right here. This is what theta is. Let's take this over here, okay, just to make it bigger. Theta divided by 2, okay? That means I would also have to divide the left side of the inequality by 2. And I would also have to divide the right side of the inequality by 2. Dividing by 2 is like multiplying by a half. So now, half of theta, it's going to be pi over 2 to 3 pi over 4. Well, where is that? Pi over 2 is right here, right? And then 3 pi over 4 is right here. So you are in quadrant number 2. So half angle is really in quad 2. In quad 2, sine would be positive. I'm writing the positive down, but eventually I'm not going to because, you know, I don't need to carry the positive, right? Positive, if it's negative, I would definitely have to carry it throughout. So here we go. 1 minus cosine of theta, it's already known, back to here, okay? So cosine theta is negative 2 divided by 5. Divide all of this by 2, which I'm going to write it as a multiplication of a half. And from here, let's do some basic math. Big radical again. I'm going to find the common denominator, which is now 5 over 5. 2 additions make it positive. I'm sorry, 2 subtractions make it positive. 2/5 times a half. Okay, this is going to give me 7 over 5 times a half. So that's going to give me what? What would that give me? 7 over 10. Okay. Now that's like radical 7 over radical 10, which now I need to rationalize the denominator. Okay, so here comes my final answer. Are you ready? Big radical 70 all over 10. Okay, and radical 70 is 7 times 10, which neither one of those is going to help us simplify. All right, so that is 3i. Now we are going to do 4i's. I'm going to use different color. 4i's is half angle of cosine. Okay, let's move it over here. Now, just to remind you, if you need to pause to finish copying, then do so. Okay, so cosine of a half angle over 2 equals, again, plus or minus big radical 1 plus cosine of theta divided by 2. Now we have to go back and decide whether we pick negative or positive, okay? Earlier we mentioned about half angle, and half angle of theta is in quadrant number 2, okay? The original theta, was in quad 3, but half of it's now in quad 2. In quad 2, cosine is definitely going to be negative. So now I have to carry the negative sign in front all the way through. So now I'm going to write 1 plus negative, cosine is negative 2 over 5, okay, because that's what we have right here. Okay, now dividing by 2 is like multiply by 1/2, so I'm going to do that. Then from here, I will slowly simplify this. Common denominator again, which is 5 over 5. Take away 2 over 5. Now times a half again. Okay, I'm out of space, so that goes here, which is now still negative in the front. 5 over 2 minus 2 over 5 is now going to be 3 over 5 times a half is now 3 over 10. So now 3 over 10 is exactly the same as negative rad 3 over 10. I would now have to rationalize the denominator. So here comes the finale, negative answer, rad 30 all over 10. And that is my final answer for 4i's. All right, let's see. So that's 1i, 2i's, 3i's, 4i. We have 2 more, okay? Tangent of double and tangent of a half. So notice how we're kind of doing all of them, okay? So, excuse me. Let's use green, okay? We are going to do 5. Tangent of a double. Tangent of a double, here we go. For this tangent of a double, I'm using this identity. I'm using 2 tangent of theta all over 1 minus tangent square of theta, okay? So from here, I'm going to slowly find out what tangent is. So work with me, okay? So here we go. Let's go back to the triangle. Tangent is going to be opposite, okay? So tangent is going to be opposite over adjacent. So opposite is negative 2. I'm sorry. Oh my gosh. Opposite is not negative 2. Opposite is negative 20 root 21 over adjacent, which is negative 2. So this is opposite. This is adjacent. Okay. So opposite is negative root 21 over negative 2. So a negative over negative is going to be a positive. Okay. So tangent of theta is positive root 21 over 2. So let's start writing. I'm going to bring down the 2. Okay. And we just mentioned that tangent is opposite, which is negative root 21 over negative 2, which is a positive root 21 over 2. Okay, that's my numerator. Divided by 1 minus tangent square. I already have the tangent, so I'm just going to put the square. Square root of 21 over 2. Then from here, I'm going to slowly work this out, cancel out things when I can. I can totally make the 2 into a fraction, so these 2 will cancel. Okay, so on the top, I now will have square root of 21 divided by, on the bottom, I will distribute the square power. So here we go. When I distribute the square power, I would now have 1 minus, about 21 squared is 21. 2 squared on the bottom is now 4. Then from here, I'm going to attempt to find common denominator. Okay, so now it's going to be around 21, still, all over 4 over 4 minus 21 over 4. So now around 21 on the top still, all over. 4 take away 21 is going to be a negative 17 over 4. Now when you're dividing fraction, that's like multiplying, it's reciprocal. I will make the numerator over 1, okay? Times the reciprocal is 4 over negative 17, or you can put the negative in the front. Then from here, I will have negative, I'm going to put the negative on the top, 4 rad 21 all over 17. And this is as far as I can go in terms of simplifying. Because 21 is 3 times 7, and that's not going to help us out at all, okay? So that is 5i's. We have one last one, which is 6i. 6i is going to ask us to do the half angle of tangent, okay? So here we go. 6i's. Now, if you don't have enough space, just do it on the back of your notes or on scratch paper, and just you can just attach it, okay? 6i is asking us to do tangent of a half angle of theta. So I'm going to use sine of half angle divided by cosine of half angle. I'm pretty sure that there are other formulas or other ways that you can find half angle, but this to me is one less thing for me to memorize, okay? So I'm going to use 1 minus cosine of theta all over radical 1 plus cosine of theta, okay? And then again, there's still plus or minus in front, so we have to decide. Let's go back to our half. Half angle, it's going to be in quad 2, or was decided earlier from calculation, that's in quad 2. So because it is in quad 2, I'm going to pick the negative for tangent. So negative, big radical, 1 minus cosine earlier was given in the original problem right here, okay, as negative 2/5. So negative 2/5 divided by 1 plus negative 2/5, okay? From here, there are multiple ways to simplify, okay? So you go and simplify whatever method you wish. I'm just going to start with finding common denominator. So carry the negative over. Common denominator is 5 over 5 plus 2 over 5, okay, divided by 5 over 5 minus 2 over 5. And keep on going. So here we go. So on the top, I would have a negative square root of 7 over 5, okay? All over, on the bottom, I would now have a square root of 3 over 5. Two different radicals can be put together as one big radical, so keep that in mind. So 7 over 5, like divided by one big radical, 3 over 5, like that. When you're dividing fractions, it's like multiplying by its reciprocal, so here we go. 7 over 5 times 5 over 3. That's the reciprocal. So now that's the case, I will cancel out my 5's, okay? And I would now have a negative radical 7. Because it's under one big radical, now I will break it out to make smaller. The reason is that some of you will understand how I rationalize better when I break it apart. So this will lead me to a negative square root, equals to negative square root of 21 all over 3. And this is my final answer for 6i's, tangent of a half angle. Now, if this seems really confusing, please do pause, rewind a little bit wherever you were stuck at. I wrote down every single step that I can think of. If it's still not clicking, please ask me questions in class. And you have a wonderful day.
You can celebrate because example 4, establish the identity, is our last example in 7.6 notes, okay? So here we go. cosecant of 2 theta equals half times secant of theta times cosecant of theta. Now, when you're establishing an identity and it has half angle or it has double angle, then that's the side that you want to start with, okay? So always start on the double angle identity. So my step 1, I would do cosecant of the double angle. I never really gave you any identity that dealt with cotangent, cosecant, or secant, but that doesn't mean I can't find it. Cosecant is just typically 1 over sine of a double, okay? So cosecant of a double is 1 over sine of a double. Well, I definitely know what sine of a double is. Sine of a double angle is 2 times sine of theta times cosine of theta, okay? Well, my goal, here's my goal. I want it to be 1/2 times secant of theta times cosecant of theta. Well, 1 divided by anything, I can break this up, is really 1 over 2 times 1 over sine of theta times 1 over cosine of theta. Because when you multiply across. So all the numerators are still 1. So, well, step 5, 1/2 is 1/2. 1 over sine is cosecant of theta, and 1 over cosine is secant of theta. Even though I switched the cosecant and secant, but guess what? It doesn't matter because in in multiplication, you can move things back and forth, right? You can multiply 2 times 3 is the same as 3 times 2, so it's totally okay. And because this looks exactly the same, I am so done, yay!